But our learning goal adds to it, I can set up a system of linear equations to problem solve and then solve by graphing. So in the homework that you have, you're going to be doing some just solving systems of linear equations by graphing that you have no idea what the equations represent. And then there are going to be other times that you're going to have to set up your own system of linear equations to help you problem solve, much like we did yesterday with the ticket problem and the point problem, right? We did that yesterday on that tan sheet. So it says set up a system of equations with two different variables, use a graph to find the solution. So here's our first of two problems that we're going to do together. Several books are on sale at a bookstore. Some of the books sold for $3. Others sold for how much, AJ? $5. One day last week, 80 books were sold. The total amount of the sale was $300. How many of each type was sold? So you know what I want you to do first of all? I want you to circle that question because the question that they ask just directs you to what your unknowns are. So oftentimes when students are trying to describe the unknowns and pick the variables to do it, they assign the variables to something that's already known. And we need to assign them to something that's unknown. And that question says it right there, doesn't it? How many of each type were sold? Does it have anything to do with a dollar amount? No, we're not going to answer that. We're going to answer how many $3 books were sold, how many $5 books were sold. So that's already been chosen for us. We're always going to describe, so again, let's put a box around that. We're always going to describe the variables. So let X represent the number of $3 books, Y represent the number of $5 books. Okay, I've written out a couple of word sentences to help us set up equations then. See if you can come up with two equations given what X and Y represent and the information provided for you. Set up two linear equations. One underneath the first word sentence which says number of $3 books plus number of $5 books equals the total number of books. And then underneath the other one, dollar sales of $3 books plus dollar sales of $5 books equals total dollar sales. See how we did this yesterday. And by the way, remember you can't add minutes to minutes and get dollars, or you can't add something like miles and miles and get rate, speed. Whatever we're adding together or subtracting with, that's what has to be represented on the other side. That's what the equal sign says. They're the same. Okay, first equation, who's going to offer it up for me? Josh?
X plus Y equals 80.
Yeah, X, the number of $3 books, plus Y, the number of $5 books, equals 80. We sold 80 books altogether. Okay? Number of books plus number of books is total number of books. We're adding number of books together and getting a total of number of books. Okay, how about this second equation? Katie, you got that one for us?
Yeah. 3x plus 5y equals 200.
If you take $3 times the total number of $3 books, that's going to give you the dollar sales of $3 books. If you take 5 times the number of $5 books, that's going to tell you how many dollars were taken in sales of $5 books. Add those two together, you should get $300, the amount that they took in. Okay, so seem like good equations, both of them? Okay, so if we're going to solve by graphing, we need to get them, we need to graph each of them. So the first thing we need to do is what?
Get them in slope-intercept.
Get them in slope-intercept form. So X plus Y equals 80 is not in slope-intercept form, nor is 3X plus 5Y equals 300 in slope-intercept form. So go ahead and get those rearranged into slope-intercept form. you done? Did you beat me? Oh, did I do? It was you who were done. All right. Yeah. Well, let's get them ready and continue getting them ready to graph. Let's say what M equals and B equals for each of them. Okay, now before we graph, we have to get a graph set up for this. We have to, you know. Why do you think I only have quadrant 1 there?
Because it's always gonna be.
Positives, yeah. And what happens in quadrant 1? We have both positive x values and positive y values. And since x represents a number of books, can't have negative number of books, right? And y represents another number of books, can't have negative number of books, so we don't need any negatives. So quadrant 1. So let's title the x-axis and the y-axis. Let's start there. So we're going to say, what for the x-axis?
Number 3.
Yeah, number of $3 books. I've already chosen a scale for us, it looks like, on that axis. What did I choose? 1 by 5, so 5 books at a time. So it might get a little busy if you try to label every grid line, but let's give some number labels to some grid lines going across so that our graph is readable, okay? I have to do some calibrating before I can, so you guys go ahead and number across. You can either decide to label every one, or you can go every other. I would not recommend every 6 or 7. That's a little bit weak, not very useful. And then you can go ahead, if you're done with that, you can label, give a title to the y-axis and notice what the scale is there and finish doing some numbering. And we should give a title to the whole thing. What should we call it? What's going on? Where is this happening at?
Bookstore.
Bookstore. Let's just call it bookstore. They might publish this in the paper. We gotta have, enough information for everybody. Okay, so now we gotta get ready to graph it. Okay, well, when both axes are not going by just 1 unit at a time, do we have to pay attention to that? Would that be important?
Yeah.
Yeah, because for this first one, it starts at 80. Okay, so it starts at 80. It has a y-intercept of 80, right? Right here. And its slope is -1. So we could put that -1 over 1, right?
Yeah.
Do you really want to go down just 1 unit and over 1?
No, you can do -5.
So we could rename it so that our scale is better used, right? So negative, if we multiply both the top and the bottom by 5, we still have -1, do we not?
Yeah.
Okay, now we can go down 5 books at a time instead of just 1 book at a time and over 5 books at a time, right? Okay, make a whole bunch of points. I am going to tell you that on these word problem ones, you need to make sure you're making so many points, you're just like, wishing that there was more important playing so you could just keep at it. Because we will not be able to tell a good solution if we just make the 3 points sometimes and the 3 points for the other one, and then somewhere else on the graph a long ways away from those points, they're intersecting. And sometimes it gets thrown off just by how you place your ruler through the points, okay? So, just go crazy. Just make a whole bunch of them. It's so fun. So easy on this one. I mean, jeepers. I gave you rulers already, right?
Yeah.
Okay. Should it be a line, ray, line segment? Line segment, because again, we don't have such a thing as negative books, so we'll just connect the axes together, okay? Okay, let's go look at the other one. The other one starts at 60, so we'll go to 60 and plot ourselves a point. And then its slope is -3/5. So that would mean go down 3 books and over 5. Is that the way you think we should do it?
No.
Yes, somebody just said.
No.
No? What would be nice to have those both be? Multiples of 5, right? So what could we rename -3/5 as? We could take,
-15.
yeah, we could take both of those times 5 because, and we have -15/25 instead. Gonna make it, now, here's the thing you gotta be careful of though, and I hope you were careful on the other one. And sometimes you get away with it in this one, in that first one, you would get away with it, and so would you in this one, but if you just went down, you know, like 5 and over 5, you'd get away with it. If you went down 15, I don't know if we have enough grid lines, but if you went down 15 and over 25 grid lines, you'd get away with it. Anybody know why you would get away with it?
This is so point on the line.
The scale is the same for both axes.
Yeah.
That's the only reason we would get away with it, okay? So instead, I like to think of it like this. I am going down 15 books and over 25 books. So 15 books would be how many grid lines? 3. And 25 books would be how many grid lines? Oh, look at there. It almost seems like we didn't need to rename slope, doesn't it? Down 15 books again, over 25 books again, down 15 books, over 25, and just for the fun of it, I think I'll just keep going down to that corner. Line, ray, line segment. Line segment. Okay, it looks like I've provided the spot where we're going to write our ordered pair solution. What is it? Where are our line
50,
segments?
30.
50, 30. Okay. Whoopsie, I have a line tool yet. 50, 30. Everybody agree? Look at your graph and make sure.
Yeah.
Okay. Which tells us what then?
And 50 of the $3 books are sold and 30.
Okay. 50 of the $3 books were sold and 30 of the $5 books were sold. And how can we check our answer? I mean, not even thinking about the equation. Because what if you set up bad equations? Let's go back to the information they gave us in the beginning. What did they tell us in the beginning?
That's several books.
They sold 80 books altogether. So 50 plus 30, what's that equal? 80. 80 books, that checks. What else did they tell us?
Wow.
$300, okay. Okay, so if there are $53 books, we would take 3 times the 50, plus we would have to take 5 times the 30, because there's $35 books. And let's see what we get. We get 150 plus 150, and that equals 300. And those would be dollars, checks, right? Okay, so it makes sense back to the original information they gave us. So if you didn't set up your equations correctly, then probably in the end, the answer you got would probably not make sense to what they told you in the beginning either, okay? So, questions? Okay, let's go to the backside then and do one more together. Okay, Andrew, read that for us, please.
American Good, the Meadow Super Bowl party catered budget burger charges $120 plus $10 per person. Viking charges $150 plus $80 per person. Find the number of people, which the total cost is the same for both.
Okay, so maybe it's just like, he asked some of his friends, which one would you like? And they say budget burger, and a bunch of others say, well, no, we think the food from the Viking room is better. And you're trying to decide which set of friends you should satisfy, Kind of like, well, it was kind of a toss-up, so now I didn't get anywhere, so do I just flip a coin? No, let's figure out how many people I would invite, the cost would be the same, and then I'll flip that coin and see, okay? So, let X represent. Well, let's circle, what is it we're supposed to find?
The number of people.
Find the number of people. Is that one unknown or two?
One.
That's just one.
The total is.
Yeah, for total cost. So we need when the number of people when that total cost is going to be the same. So we don't know what that total cost is going to be. We don't know how many people that's going to be. So those are our two unknowns. So let's let X represent what?
The number of people.
Okay, number of people. How many of these crazy friends of yours you're going to invite? And Y would be what? Total cost. Okay. So now I have budget burger arrow and I have the Viking room arrow. What do you think I want you to do?
Equation.
Yeah, write equations, try it. Write equations for what could represent us getting the food from budget burger and represents getting it from the Viking room. Okay, Chase, would you share with me your equation for budget burger?
Y equals 120 plus 10x.
So Chase says Y equals 120 plus 10x. Anybody else have that equation?
Yeah.
I do, Chase, I do, I do know. You do, yeah. The total cost can be arrived at equals by taking the $120, that's only a one-time charge, right? Yeah, just for, just for hiring them, you have to pay $120. Plus 10 times X, what's that giving us?
The number of people.
The number of people multiplied times the dollar amount for each person, that gives you the total dollars you're going to spend for how many people you invite, right? So dollars plus dollars equals dollars. That seems reasonable, doesn't it? Okay? How about the Viking room? The Viking room. AJ, will you share yours with me, please?
Y equals 8x plus, or, yeah, y equals 8x plus 1.
Okay. Anybody else have that equation?
Yeah.
Does it matter that maybe your algebraic expression on the right side, which is also known as the function rule, that would be turned around? Does it matter that?
No.
No, because it really doesn't matter, does it? Okay, so what's cool about these equations?
They're in slope-intercept form.
Yes, they're slope-intercept form, which makes them
Easy to work with.
easy to work with, easy to graph, right? Okay, so let's get busy and let's come over here though and let's decide what's our M value for this one and what's our B value and what's our M value for this one and what's our B value. In other words, let's really get serious about graphing then. Okay, well, I'm thinking maybe before we start we should do what?
Change our slopes.
Possibly,
no,
yeah.
Yeah, that's.
Fix our, finish our graphs.
Get our graph set up, right? Get our coordinate plane, our display of it set up here. So we need to title the axes, we need to title the graph, total graph period, we need to number out our axes. So what would be a good title for our graph here?
The actual, for the graph,
For the whole graph?
Super Bowl party.
Super Bowl party, yes. We are having a Super Bowl party. And then we will say, what did we say the X's are representing?
The actual number of people.
Yeah, number of people, number of guests, whatever you want to call them. And what scale am I using on the x-axis? Going by ones. Okay, well then we better get some numbering done here. Not labeling out your axes is going to cost you points on assessments because you know what? No one who looks at your graph should have to work terribly hard to figure out where an answer. Okay, how about the y-axis? What are we going to call it? Total cost, and what's it measured in? We always have to say that too. Dollars? Millions of dollars or
Just dollars.
just dollars? Okay. Because it could be pennies, it could be hundreds of dollars, it could be thousands of dollars, it could be millions, and so that we could just leave all the zeros off, but we're gonna just do dollars, okay. And the y-axis is going by
20.
$20 at a time. Sometimes I get myself in trouble by having to skip lines, so be careful. Like me, I think I just did that. Sometimes it might be worth just labeling every grid line so you don't mess up. Like I think I'm doing right now, 260, 220, 260, 300, 340. I can't even read what I'm writing here. Would the top grid line be $400?
Yeah.
Yeah, okay, then I'm all right. Okay, let's get ready to graph. The first one that starts at 120. So right down here. And it has a slope of 10. Do you think that's a friendly slope for this graph?
No.
Not necessarily. So let's come over here and say m equals 10. Well, we can put it over 1. What should we rename that as?
20 over 2.
20 over 2 because multiples of 20 would be nice. So 20 over 2. Okay, so that means we're going up $20 and over 2 persons. So we have to be really careful because if you would have gone up 20 grid lines and over 2, would that have worked?
No.
No, that wouldn't have worked. So we have to make sure that we're paying attention to what are these numbers representing, and we actually graph what it's saying, even though it doesn't look like. It looks like a slope of what right now? If this was dead scales of 1, it looks like a slope of what?
1/2.
1/2. Yeah, well, that isn't our slope, is it? No. So we have to be really careful. Line segment, ray, line,
Ray.
ray. Whoever's having this party invited as many people as they want. It just happens to stop at 20 on our graph, doesn't it?
Yes.
Okay. Now let's get the other one ready to graph. What was its y-intercept is 150. 150. That's going to be
Somewhere half.
kind of halfway between a couple grid lines, right? Yeah. And its slope is 8. Okay, so is 8 a good friendly slope?
No.
No.
We get to just
We need, what did we say would be nice to have? So multiples of 20.
so 40.
Oh, 40 is a multiple of 20. And what times 8 is 40? 5, okay, so we'll take 8 over 1, and we'll multiply both by 5, and now we'll have $40 at a time over 5 persons at a time, or people. Now, we can go up 40, and over 5 persons. And draw your line segment array. Line segment? Ray again, right? These get pretty tricky, so you gotta be really good with doing your graphing. Those lines get pretty tight, don't they? They like each other. When you think you know the ordered pair, write it down. Where are those two lines intersecting on the graph? What'd you get, Devin?
15 and 270.
Devin got 15 and 270. Anybody else get that? Is that a hand up, Andrew? Or you're not sure yet? Devin, so far you stand alone. 15 and 250.
I know, and I get 270. Sure you're going up 40 every time?
Sure, in other words, are you sure you labeled your y-axis right?
That could be too.
What'd you get, AJ?
Check my work.
14 to 40. What'd you get, Chase? You got 15 to 50. Oh my goodness, we got all kinds of options.
Can't there be more?
Can there be more than one, do you think?
No,
No,
because it's
They're
7.
really only intersecting at one point, even though it looks like there, might be more. So I'm thinking right now with all the different choices we've gotten for answers, it's pretty critical how well we graph, isn't it?
I think I'm right. But I checked my work.
Well, you checked your work, Devin. How does it check out, Devin?
Well, it equals, because if you do 270 equals 10 times 15 plus 120, it equals 270.
So it checks out in both of them, the x value checks out in both of them. Or you could also say, you could just like disregard our equations and say, if I pay $120 to hire Budget Burger and they charge $10 per person, that's 10 times 15, that's $150, and 150 plus 120 is 270, right? And if I hire Viking Room, they charge $150 up front, but they only charge $8 per person, and 8 times 15 people would be
120.
$120, and $120 plus $150 is? Yeah, Devin has the right answer. It should be, and so if you didn't get it, you need to probably regraph that on your own time here and figure out how, maybe you need to check your labeling on your y-axis, that was the tricky one. Check you're doing your slope because we had halfway marks, okay? So this basically tells us then that when Derek invites how many people? 15 people, the total cost will be the same, and that cost will be, we decided, $270, okay? So then, if he's only gonna have 15 guests, he can flip a coin and say, that, you know, just like they how they start the football game, I guess, flip a coin, this is who I'm going with. But, if he's going to, you know, if he's like, not gonna invite 15 people, exactly. What if he doesn't have as many friends, or he wants the party to be smaller, or whatever the reason? And, or maybe he has so many people he wants to invite. So then maybe those, because of that, that's then it's like, well, but I don't want to spend any more money than I have to. So the question is, I want you to answer that. Explain when it is cheaper for Derek to hire Budget Burger to cater his party. When is it cheaper? Not the same cost, but cheaper to hire Budget Burger. And when is it cheaper to hire the Viking Room? And include in your explanation how the graph supports it. Start writing. We got all kinds of white space there to do your explaining. Anybody got to figure it out when it's cheaper to hire a Budget Burger? Austin?
It's cheaper to hire Budget Burger if there's less than 15 people.
Okay, so if he invites less than 15 people, it's going to be cheaper for Budget Burger. Okay, how does the graph support that?
Well, the burger line is below the Viking room, like the price until it hits 15 people and then it goes above.
Okay, so what would be kind of helpful on the graph? Call this line BB for Budget Burger, and call this line VR for Viking Room. And when we look on the graph, we can see that I did mine in different colors, so it's a lot easier to see. And sometimes you might want to do this when you're graphing problems like this. It might be helpful to use colors or some highlighting or something to help you out. But right here, this is Budget Burger's line up to that point, and it is below the Viking Rooms, isn't it? So that, remember, the Y's are the what? The what? The cost. So that's representing the dollars. So dollars are less at that part of the line, aren't they? So if he's going to invite less than 15 people, go with Budget Burger. If he's going to invite more than 15 people,
Go with Viking.
go with the Viking Room. Okay. So I will finish filling in the rest of just that part. A line of the equation for Budget Burger is below the line of the equation for the Viking Room. And then, of course, we would just state it the opposite for the other way, right?
Yep.
Questions? Okay, what was the trickiest, hardest part about these word problems? What do you see might be a challenge?
Getting your equation right.
Yeah.
Okay, first of all, might be a challenge just getting the, being able to tell where they intersect. What else could also be a challenge?
Figure out which one's actually.
figure out what's gonna be your X and what's gonna be your Y, making sure you're describing those correctly. What else might be a challenge? Maybe getting it into slope intercept form. What else could possibly be a challenge?
Getting it right.
Getting it right? Yeah, okay, so we have to be, you're gonna have to be, you know, like, with the word problems, you're gonna need to make lots of points, because the more points you make, you start to be able to see where they are going to intersect. It makes it more clear. Now, the other thing that I caution you on, especially on these word problems, think about on this one, if we made all the points for budget burger, and then did not draw the array, we just said, okay, well, I'm gonna get the other one graphed too, and then I'll pick up my ruler and I'll take care of both of them. And then, so we have all these points going for biking room next. Would you have been able to tell where you should draw your lines? No. Absolutely not, it would have driven you crazy. So that's why I keep saying to you, graph one line at a time. Finish one before you start the other, okay? Set yourself up for success. Questions?